everyone, this is Hajra Mughal. Welcome back to my YouTube channel Physics Unlocked. Today we are going to dive into a fascinating topic that will change the way you think about one of the most essential substances on our planet, water. Yes, you might have already figured it out, or maybe you are curious to know. We are going to explore the triple point of water, a unique phenomena where solid, ice, liquid water and water vapor coexist in a perfect harmony. From the freezing tundra to the boiling oceans, water's triple point plays a crucial role in shaping our planet's climate and weather patterns. So let's unlock the physics behind this incredible phenomena and discover the secrets of the triple point of water. States of matter. Water can exist in three main states of water. Solid, also known as ice. Water molecules are arranged in a crystalline structure with a fixed position and vibrations. Liquid, water. Water molecules are close together but free to move with some attraction between them. And in gas, also known as water vapors. So water molecules are widely spaced with minimal attraction and are free to move randomly. Okay, so students, phase transitions of water occur when water changes from one state to another, such as solid to liquid. Solid to liquid is known as the melting point or melting. Liquid to solid is freezing. Liquid to gas is vaporization or known as evaporation. Gaseous state to liquid, condensation, and from solid to gas is sublimation, and again gas to solid is deposition. So students, what is triple point of water? So you know how water can be a solid or a liquid or a gas. Well, there is a very cool point called the triple point where all three of these states exist at the same time. It's like a special meeting point where ice, water and water vapor are all in balance. This happens at a very specific temperature, 0.01 degrees Celsius, and at a specific pressure, 611.6 pascals. Imagine being at this exact point where you can see ice melting into water, water evaporating into vapor, and vapor condensing back into water, all happening simultaneously. It's a unique and fascinating phenomena that helps us understand the properties of water and how it behaves under different conditions. So what is the definition? In thermodynamics, a substance triple point is a unique combination of temperature and pressure at which solid phase, liquid phase and gaseous phase can all coexist in a thermodynamic equilibrium. And what is that particular temperature and pressure? It's a 0.01 degrees Celsius and 611.66 pascals. Let's take a look at this short demonstration video. If we place ice cubes in a enclosed container and apply heat from the bottom, a phase transition can be observed. Observe how the ice melts into water, water evaporates into vapor, and vapor condenses back into water, all happening simultaneously at the triple point. This phenomena is crucial in understanding the properties of water and its behavior under different conditions. So students, a phase diagram is a graphical representation of the physical states of substance, solid, liquid and gas as a function of temperature and pressure. The triple point phase diagram is a specific type of phase diagram that shows the triple point where the solid, liquid and gas phase of a substance coexist in equilibrium. This is the point where solid liquid, liquid gas and solid gas equilibrium line meets. This is the unique temperature and pressure at which all three phases coexist. Now, what is meant by these equilibrium lines? Solid and liquid equilibrium line, where it separates the solid and liquid phase, and this line is known as the melting freezing line. And this is the line, the liquid and the gas equilibrium line, known as vaporization curve, that separates the liquid and the gas phases. And this is the line known as the solid gas equilibrium line, also known as the sublimation curve, and it separates the solid and gaseous phase. So here is a more brief explanation of the triple point. So let's say this is the point, and I'm giving it name as T1 and the pressure P1. At this point, all three phases, solid, liquid and gases, coexist in equilibrium. And if we raise the temperature, let's say, to any other point in the region, so we will reach a region where only two phases, liquid or gas, exist. Okay, so basically these lines, what these lines represent? These lines represent the phase transitions. Any point on these lines will represent the specific temperature and pressure condition where two phases coexist. Okay, let us consider any point X here, any point X. Let's say it has a temperature T2 and the pressure P2, which falls vertically within the vapor phase. Okay, so by drawing vertical and horizontal lines here, vertical and horizontal lines from the point X, we can determine the pressure and the temperature at this specific condition. Okay, conversely, if we know the temperature and pressure values, so we can use the phase diagram to determine the phase of the matter. This is a powerful tool for understanding the behavior of the substance under different conditions. Okay, so students, in a triple point phase diagram, there is a point known as the critical point. At this point, the liquid phase equilibrium line ends. It is the highest point at which the temperature and pressure coexist in a liquid and gas phase. At this critical point, the liquid and gas phase become indistinguishable. Second thing, the density of the liquid and gas becomes equal. And third point is the heat of vaporization becomes zero. Beyond this line, this point, there is no distinct liquid gas phase transition, and the substance will known as supercritical fluid. The critical point is characterized by the critical point, critical temperature. It's a highest temperature at which liquid and gas phases can coexist. Critical pressure, the highest pressure at which the liquid and gas phases can coexist. And critical density, the density of the substance at the critical point, and at this point the liquid and gas both have the same density, and means the densities becomes equal. Okay, so the critical point marks the end of the liquid gas equilibrium line and is an important reference point in phasor diagram. Okay, so now what is the supercritical fluid? A supercritical fluid is a state of matter that occurs when a substance is subjected to temperatures and pressures above its critical point. At this point, the liquid and gas phases become indistinguishable, means you can't distinguish either it is a liquid or gas, and the substance exhibits unique properties. What could be its characteristics? First characteristic is the substance can't be classified as liquid or gas. You can't indistinguish. Okay. And the second property is it has high density, even higher than those of the liquids. Third one will be it has high diffusivity, like can diffuse through the material like gases but with higher solubility. And they will have low viscosity means making them flow easily. And the last one is the tunable solubility. It means they can be adjusted by changing temperature and pressure. The following table lists the triple point data for different substances, showcasing their unique pressure and temperature values at which solid, liquid, and gas phases coexist in equilibrium. Thank you so much for watching. Don't forget to subscribe to my channel Physics Unlock for more exciting content. Please hit the like button and share your thoughts on the video in the comment below. Your support and feedback are invaluable to me, and I look forward to hearing your perspectives on the triple point of water. Let's keep exploring the wonders of physics together. Thank you.